Hello and welcome for the Data Science Demo Day, the batch number 672. Welcome everyone that is joining us remotely via Zoom. Welcome also to our wonderful students. So for the souls on Zoom, you can't see, but the room is absolutely filled with our students, our 27 beautiful students over here, the teachers, the TAs, and the team as well. So my name is Tom. I'm taking care of community and events here for Le Wagon. And so today I would like to welcome you officially for the demo day of the Data Science Bootcamp. So a little round of applause. That would be nice, thank you. So I think for the people joining remotely, you can hear that the atmosphere is already on fire. For those of you remotely who want to also participate in the enthusiasm, please do not forget to put a round of emoji to also share your experience with us on the chat. That would be wonderful. Everyone is watching as well. So yeah, please join us in doing that. So today we have 27 students. They started the adventure on the 5th of July for 9 beautiful and intense weeks. I'm pretty sure that they will all tell you that the experience was not really what they expected. They've been tired, they've been happy, they've been depressed, and now they are extremely looking forward to this last presentation. Talking about or speaking about presentation, we're going to have 7 of them today. So before we go into the content that is the most interesting part, the event will be as follow. First, my dear colleague Annie will take the microphone and give you a tiny bit of a presentation about Le Wagon. That's especially for you who are remote and might not know Le Wagon. But even if you know a tiny bit of Le Wagon already, it doesn't hurt to know a tiny bit more of this wonderful project that we are all part of. And then after that, we are going to have Davey, who's going to present all the students and their all projects. So yeah, before I bore you with everything, I leave the stage with Annie, and thank you so much for joining us today.
Welcome everybody by this amazing day. I'm so proud of all the happy faces sitting in front of me. For those who don't know me, people at home maybe in Zoom, my name is Annie. I'm the city manager of Le Wagon here in Berlin, and I first want to thank everybody who's here with me, who organized this amazing day. I know the amount of hours that has been gone in it, and it's quite a bit. So thanks so much team, thanks so much students for the preparations for today. So before we go to the amazing 7 projects that we have for today, I want to give a short intro about what is Le Wagon. Because there's quite a few things that you need to know. But I can imagine there's a few of you before you even enrolled, or maybe before you want to sign up. You have a few questions. For example, it's super frustrating. I don't have any technical skills to build my models. However, I have an amazing startup idea, and I don't know how to do it. Okay, it's working again? Nice. So you might be working with an amazing team, amazing engineers. You have a lot of data, but you don't have a clue how to challenge them. Because, they're speaking kind of an ancient Greek, and you don't know what is happening. Or you want to switch careers, right? You have been working in printed media, maybe something else that is kind of old. You want to switch careers, and you don't know what to do. So that is where this is basically who you are. So this is where Le Wagon comes in. We bring technical skills to creative people like you, and we will help you with quite a few things. For example, find a career as a data engineer. We'll teach you how to code so you can become a freelancer, digital nomad. We'll teach you how to set up your own startup, and also how to transition in this data role, so how you can reinvent yourself as a person as well. We do that with 2 different bootcamps. One of them is the web development bootcamp, where we teach people within 9 weeks to become a full stack developer. And they'll set up the front end, the back end, and they can basically make a fully functioning web app. And the other, of course, is a data science bootcamp, where we are right now. I'm not going to spend too much time on it, because here we go. There's a curriculum of 9 weeks. Within these 9 weeks, there's 450 hours of quite a lot of hard work. I think that 450 hours might be an understatement for some of you. I know there's a lot of extra hours going in. However, we teach you all of the skills how to become a perfect data engineer or join a data team. There's a lot of prep work before. We teach you with Python, data analysis, SQL. We deep dive into decision science, machine learning we touch upon, and then afterwards we go into deep learning. There will be quite a few cool projects that you see what you can do with just these 9 weeks. What you do is created in the last 2 weeks of the bootcamp. The thing is that there is not everybody has the luxury, of course, to quit their job for 9 weeks, or they're studying and they don't know what to do next to it. So we also have a part-time bootcamp where you can learn exactly the same, but over 24 weeks. I have to say we have gotten pretty good at it. We're the #1 rated coding bootcamp in the startup part of Europe, and it's something that I'm very proud of. Yes, thank you. But it's of course pretty important to know where our alumni end up, right? Who is hiring them? Why are you doing this bootcamp? Think about one of the hottest fintech startups, Moonfair. We have Urban Sports Club, Adjust, a lot of very cool startups here in Berlin. But also you have the opportunity to build your own startup. And yeah, these are a few startups that have been founded by our alumni. And all of these startups have been raising quite a bit of money. It's over 250 million euros already with the 70 startups together. So that's of course a pretty nice goal. Who are these alumni? Think about Danny. He was working as a design thinker and coach, realized this was not for him, and he wanted to do something else. He did our bootcamp and is now the data analyst lead of Paul Kemper. Then we have Francois. He was working in sales first and realized that was not necessarily his life goal. He did our web development bootcamp and started working as a product manager. And then he got in touch with a lot of data, realized like, hey, this might be my passion. He did a data science bootcamp in Paris, and now he is working as a data engineer. And then we also have Brigitte. She was working as a trading intern, and now, after the bootcamp, is a data consultant. So there's multiple ways to fund the bootcamp as well, because it's of course quite a commitment. One of them is the Bildungsgutschein, and this Bildungsgutschein is a voucher from the German state that will cover your complete tuition. And we have another financing option, and that is an income share agreement, where Janssen AG, it's our partner, they pay the bootcamp up front, and afterwards you will pay back after you found a job. What do you get for this? Of course, you get the bootcamp. You have 9 weeks of quite a lot of lectures, challenges, but afterwards you have a lifelong access to all of the learning materials that keep on being updated for you. There's a global network, over 11,000 people worldwide already, and over 1,000 people here in Berlin that you can always reach out to if you want to have any tips. And then, of course, the amazing community that you have for life. So yeah, that is it. I want to thank you for your time right now. I want to give the word to Davy and also Ben, who is, we don't know where. Davy, the word is yours. Thanks so much.
Thank you, Annie. Thank you, Annie, for this great introduction. So again, good afternoon, everyone. Welcome again, everybody, to the demo day of batch 672. This demo day is very special for me because I just arrived a few weeks ago in Berlin. So first of all, I want to thank Zuza and Ben for giving me the opportunity to co-present. Thank you so much. To the students, this is my first time on stage, so I'm a little bit nervous, but we're going to get through it together. To the audience, today you're going to see 7 incredible data science projects made by our students within the last 2 weeks, using all the knowledge they acquired during the last weeks of the bootcamp. So today, we're going to go through image recognition, natural language processing, data analysis, finance, crypto, artificial neural networks, arts, politics, and gender equality. So without any further ado, please give a warm welcome to our first group, Storage Heroes.
All right, hello everyone. So our product should basically be almost famous already, but in case you don't know what it's about, we've prepared a little trailer to give you an idea of what problem we're trying to solve. And for technical reason, there's amazing live voiceover. So.
Mulya Manta was just a regular Indian automobile engineer living between Stuttgart and Berlin when disaster struck. Her Google Drive ran out of storage space. She had to pay 10 euros a month for extra cloud storage. But there was even more news for her, worse news for her. Her photos were disorganized. A lack of organization could be a reason for exclusion from Germany. In time of great need, Storage Heroes was born. Storage Heroes coming to a pai near you. Actually, yesterday already. I hope everybody enjoy our trailer of Storage Heroes, the Python package to sort your pictures. What does our package do? I think most of us struggle with the same problem. We take more pictures than our storage can handle. We travel and become a photo enthusiast. Que bello. And then we have many similar pictures. We move our pictures around, and then we have many duplicates as well. We take bad pictures, and they are blurry. We have too many memes and screenshots. Not a bad thing, but yeah. We also cannot find the pictures we are looking for. I remember the city or the country, but I cannot remember when I have been there. Don't you worry anymore. Storage Heroes are here for you. How does it work? We find the duplicates and similar pictures using a mathematical transformation of the photos. We geotag by getting the latitude and the longitude of the picture. We reverse it to get the city, state, and country. We separate the memes and screenshots. We multi-classify the pictures into city, animal, people, and more using convolution neural networks. To explain how a CNN works, we have Captain AI here, Jonas, please.
All right, thank you, Felipe. All right, so convolutional neural networks are a little bit of deep learning magic. And there are basically two main components that make them up. The first component is a convolutional layer, and the convolutional layer is a little bit like a lens, which scans the picture bit by bit, as you can see in this nice little animation. And this kind of summarizes the information, and this allows the model to find features in the pictures. For example, if we're looking at a face, it might find things like noses, mouths, ears. And the second part is a dense layer, a dense network. And this finds patterns from the network. The dense network is basically a series of activation functions, as you can see in this nice little animation, and certain patterns of activations. For example, if you find two eyes and a nose and a mouth, and they're all in the right place, it might recognize that. All right, so now it's time for a demo. So as you should be able to see, our web package is already online on PyPy, so anyone who wants to can install it and download it. Yep. And with a simple command, pip install photos organization, which is the name of our package, you can install it on your computer, and it'll install the program as well as any required programs you need for it to run. And while that's working, we can have a look at a prepared folder we have of photos for the demonstration. While that's happening, I want to ask the audience, do any of you have problems with disorganized photos? Can I see a show of hands? Yeah, exactly. So this is really necessary. Yeah. So let's have a look at the photos. As you can see, there's some memes, very important. There's some near duplicates, like the photos of cranes. We have some pictures of animals, some landscapes. It's a bit disorganized. Some of them are blurry, so we would want this to be organized nicely. So the way to use our program is with this nifty, easy little command, photos organization run, and there's a few different options for it. If you type it with -h, then it'll show all the different options. And we've programmed it so that you can call individual features. For example, with -d or -m, you would only sort out duplicates and memes. And what we want to show you now is how the whole script runs. So if you call the function and just give a file path, it'll go into the file path and it'll start sorting. And on the right, you'll actually be able to see even live as it creates folders, sorts photos into folders. Nothing gets deleted because, well, as the data scientists among us know, machine learning isn't perfect, so you might not want it to make decisions for you, but it'll organize everything for you, and then you can have a look whether you want to keep any of the stuff that gets sorted out. And it's sorted out some duplicates, some screenshots already, some memes and blurry photos. Now it's geotagging them, as Felipe mentioned, so you can look for city and state and country information and find the related photos. And yeah, it's as you can see, it's correctly classified some memes. It's found some pictures of people, and now it's organized the rest. And when it's done, you get this nice little done message. So, last but not least, and most importantly, I'd like to thank our incredible team. So, our mastermind was Amulia, our secret weapon, Ashwidi. Yeah, thank you. Our gentle giant, Felipe. And myself. All right. Thank you, everyone.
Very good.
Okay, I don't know which mic to use, but I guess I'll just use this one. So I promised myself that I wasn't going to make any transition. So without any transition, if you've been thinking about going vegetarian in recent times, and that's something that you should be doing if you're here in Berlin, because everybody goes vegetarian and vegan here, this next presentation is for you. So the next group, what they're trying to do, they actually built a tool that's going to help you shift your diet habits towards a more sustainable habit. And they're going to present to you their tool right now. Please, without further ado, make some noise for Foodprint AI.
Is this working? Okay. Hi, everyone. We're Foodprint Ai, and our project is calculating the carbon footprint of food. So we all know that driving a car or flying in a plane emits carbon dioxide, which contributes to climate change, but are you aware of the climate impact of food production? So this is why we developed Foodprint AI. So Foodprint AI helps us make better food choices. So you can use it to learn about the climate impact of different foods, to calculate the CO2 output of your dish, and to get greener recommendations, whether that's dishes that you could have instead of the dish that you're searching, or perhaps ingredients that you could substitute in a recipe to make it more environmentally friendly. So how does Foodprint AI work, and how did we build it? Well, we started with the data. So we gathered carbon footprint data about the carbon footprint of different foods from a scientific paper and a website that aggregated a lot of this information. We gathered food and recipe data from an MIT data science project and an online recipe database. And we built a carbon footprint calculator to combine this data and make a new data set with a lot of new features or new information about the data, including the CO2 output of each dish, the carbon footprint score, so that's whether it's a low, moderate, or high carbon footprint, the confidence score, which accounts for the percentage of ingredients that we could account for in our data, nutritional info about each dish, whether the dish is vegetarian or non-vegetarian, and more. And so we took this new data set, we analyzed the data, and we present our findings. And we also took this food and recipe data and made a model to predict similar dishes from a dish input. So more about that model. We took the food and recipe data and we cleaned the data with a pre-trained deep learning model called Foodbert. We then vectorized the data, which is basically turning words into numbers. We took this vectorized data and built a predictive model where we compute the similarity of dishes based on the ingredients. So you can see, for example, we can input garlic squares, and the model will suggest similar dishes as buttery cheese dilled biscuits, cheese loaf, and cheddar biscuits as dishes that have some ingredients in common and are somewhat similar. So we combined all of this into our web app, which is Foodprint Ai and on Heroku. And you can see here, so the web app has two major features. One is showing interesting findings from our analysis of our data, and the other one is a dish search where you can find information about a specific dish. So here you can see we have some food statistics. So from over 50,000 different dishes in our data set, we found that the average carbon footprint in kilos of CO2 per kilo of food was 2.43 kilos. For vegetarian dishes, it was slightly lower, and for non-vegetarian dishes, it was much higher. Here we have the average carbon footprint per kilo of some common ingredients. So you can see that meat can have a very high carbon footprint. So beef has a 55 kilo per kilo carbon footprint. And then non-meats here tend to have a much lower carbon footprint, with vegetables and fruits all the way at the bottom of the scale. Here we visualized our data, so with dish clustering. So this interactive plot, each point is a dish, and the color of the point shows the carbon footprint. So green means low carbon footprint, yellow means moderate, and red means high. So it's really interesting to compare so this is the vegetarian dishes, and then this is the non-vegetarian dishes. So you could see that the vegetarian dishes had a lot of green points. So really, generally, a lot of dishes with a low carbon footprint, and then the non-vegetarian dishes have many more dishes with a high carbon footprint, as you can see. Then the other feature that we have is a dish search. So this allows you to search a specific dish. So you can start typing in or select a dish. So for example, shrimp and caper salad. Click Tell Me About My Dish, and then it will give you a lot of information. So it will calculate the carbon footprint. It will give you, so you can see here that the carbon footprint of this dish is estimated at 3.71 kilograms per kilo. This is a high carbon footprint, as you can see. It tells you how much data, or we have data for 98% of the ingredients. So this gives you kind of a confidence interval to let you know how accurate our estimate is likely to be. We also show the ingredients that account for most of the carbon footprint. So you can see that shrimp here account for over 80% of the carbon footprint of this dish. So if you're cooking something, you can see this and think, okay, this is what I could substitute to reduce the carbon footprint of my dish the most. We also have nutritional info about the dish. And then we recommend similar dishes. So this is using our model that outputs similar dishes. For example, if you want something like a seafood salad and you want to eat a dish that has maybe not a high carbon footprint, you could instead instead of the shrimp and caper salad, maybe you could go for a crab salad, which has a moderate carbon footprint rather than high. And this is just a visualization of some of that data. So there's a lot more that we want to do with this project. So we've already started working on an image recognition model where the idea is you could input a photo of your dish and get out the calculated carbon footprint and nutritional info of the dish. We also have the possibility of a partnership with Visiolab, which is a Berlin-based AI startup making food recognition software for automated checkouts in canteens. We have the potential to use their data or adapt their model maybe for our image recognition model and add that to our project. So this is what we've been working on. I want to thank my team for making it such an enjoyable, if intense, few weeks, and also the bootcamp for teaching us everything we needed to know to make this a reality. So thank you.
So thank you, Foodprint Ai, for this incredible product. Everybody's here. So being careful about the carbon footprint of what you eat should not stop you from being a foodie. And there are so many eating options here in Berlin for every budget. But it means that if you want to open a new restaurant, there's already a fierce competition. Where should you open your next restaurant? So I want you to give a warm welcome to Shanu, Claire, and Mohamed on stage to give us an answer about this.
So hi, thanks David to give me the mic. And yeah, my name is Shanu Dengre, and along with Claire Lombard and Mohamed Basset, I'm going to present about our project called Next Restaurant. And this is the project which is mostly focused on the users who would like to explore what kind of restaurants are there, and also more likely like if they want to open a restaurant. So why Next Restaurant is important? It's because like if somebody wants to open a restaurant, it's very crucial to know like what kind of location they want to open it. And also they want to know more information about like what kind of traffic is there, like how many people are there, or what kind of average salary of the people are in the surrounding, and more importantly, what can be their next competitor. So till now, like there is no up-to-date platform where you can get all this information, and that's where we come in. We try to combine information from different databases, and we use the data-driven approach to help the user to make much more informed decisions. And with this, I would like to give the mic to Momin, and where he will explain more about how our data is.
All right, thank you. Yeah, so as Shanu mentioned, there is currently, if you're somebody who's trying to open a restaurant, there is no one platform or source where you can go and get all your information about your competition. So of course, to build our application, we first had to obtain the data, and to do that, we used API services, specifically Google Maps, Here, and Yelp, to obtain this data about the restaurants. However, these API services have limitations. In our case, it was that the one limitation was that there is, for example, in Google Maps, a limit of 20 results per API call. So we couldn't get all of the restaurants in one call. So in order to overcome this issue, we created a list of coordinates for the city of Berlin with 10-kilometer radius and about 100 meters between each point. And we run our API calls on this point. As you can see in this image, in this chef, it's a representation of our process. Basically, every red circle is an API call, and the fact that they are overlapping circles means that we're not gonna miss. We're gonna get all the data from the restaurants, and of course, after we got our data, we cleaned it and combined it for completeness, because different data sets, different API offer different kind of data. And now I'm gonna give it to Claire to give you a demo on our app.
This is our website. When the user lands on the website, the first thing he will see is the map of Berlin. And each restaurant is represented by one dot. So there are many restaurants in Berlin. And you have blue dots and orange dots. The blue dots are the good restaurants, and the orange dots are the bad restaurants. What is defined as good and bad, like the threshold between good and bad, can be decided by the user. But by default, we gave a cutoff with a rating of 4.5 given by at least 40 users. The map already gives a visual indication of where is the best place to go. You can see where is the concentration of bad restaurants or good restaurants. And you can also filter the map using the left side panel and enter a type of cuisine, for instance, say Italian, and the map will filter to show only Italian restaurants. You can also input a district, for instance, Charlottenburg here, and the map will filter on this specific district, showing only Italian restaurants in the district, and this gives a good indication of whether it's a good idea or not to open an Italian restaurant in this district. The second thing that this website shows just below the map are key points about the user input. So here, this user will get information about Italian restaurants in Charlottenburg, but also compared with the Italian restaurants in overall Berlin, whether they have good ratings, if there are a lot already of Italian restaurants or not, if this district is popular for Italian restaurants. And right below, this is what I was telling about. You can decide or choose the threshold of what is good and bad, and the map and the keywords will also change based on what is good and bad for you. The last thing that the user can input, if they already have an area in mind, or if they have an address that, for instance, they have found a place to open a restaurant, like a rent ad or something, they can enter an address, and they will get in return information about the closest competitor just around this address. They can decide how many competitors they want to see on the map. So here, and get a second map, which is just centered around this address, and will show the restaurants around, but also 3 types of suggestion of what is the precise location to open their restaurants. The first type of suggestion is indicated by the blue marker here, if you can see it, yeah. And this is the center of the good restaurants. The second suggestion of location is the center of the bad restaurants. It's indicated by the yellow marker. And the last type of suggestion is those green markers. There are several ones, and this is the points that are the furthest away from all the restaurants in the area. And so we decided to give 3 types of best location, because it's also up to the user to decide whether he wants to actually be where all the good restaurants are, because people know that it's a good place, or if they actually want to be far away, because they just don't want to be around other competitors. That's why we give several types of suggestion. This is the current state of the website, but we have many ideas of how to improve it in the future, and also future development for this website. And Mohamed will tell us about this.
Right, thank you. Yeah, so there is, as Claire said, there is many ideas that we still want to work on, but mainly by making the data more rich and comprehensive, because the more we know about the restaurant, the more we can tell the user. One aspect is, for example, adding traffic data. For example, by adding cars and pedestrian data, we can estimate the number of potential customers. Also, the opening hours can be used to optimize the opening hour of the new restaurant compared to the neighboring competition. Also, for example, rent prices, real estate prices, and income level can also be used to optimize the pricing of the new restaurant. Yeah, thank you so much for listening to us.
So I thought it was David's turn to announce the next group, but actually it's mine. So the next group, we're diving into the crypto world right now. And I'm going to sit right here because I'm getting signs. So we're going to dive into the crypto world right now. And for those who don't know it, I'm very passionate about sports betting, speculation, all sorts of money games, to be honest. And when I was assigned to be a lead TA for this group, I was super, super excited. Actually, I assigned it to myself, and that's the perks of being a batch manager, because you can choose the projects that you want to work with. And I was very excited to work with them, but it turns out that they worked so well together that they never actually needed my help. The project was done all by themselves, or almost. Please give a warm welcome to Tim and Cryptomoon. And Ivan.
Okay, hello everybody, I'm Tim. We know the time is short, so I will just jump right into the presentation. Here you can see me and my amazing team, Frida, Ivan, and of course Jordi, last week on our venture into the cryptoverse. Our project was really related with time series data, deep learning, and also of course cryptocurrencies, because we were on a mission to find out where Bitcoin is heading. Most importantly, we wanted to focus on a shorter time frame, and we tried to answer the question whether deep learning models can actually predict the price of Bitcoin in the next 4 hours. So this is what we were trying to focus on. This does not seem to be working. Yeah, just press enter once. Because I myself, I really like to trade with cryptocurrencies, but in certain situations, it's really it's impossible to know where the price is going. So I thought it would be just super handy in some situations where you just have one tool that can just deal with large amounts of financial data and within a split second give you one output, basically just to have either your tummy feeling confirmed or to make you do more research, basically. And our strategy was to deploy a deep learning model. So I've been mentioning this term many times now, but what does that actually mean? The intuition behind this is really to create an artificial intelligence that somehow behaves like a human brain. So it's a neural network, so a network of neurons basically, but only on a computer. And you will feed data into this model gradually. And because we were dealing with time series data, we decided to go for a long short-term memory model, LSTM for short, because the intuition behind this model is that we have one string of time series data, and we would basically feed this string into the model, and gradually the model would by itself learn from the data, notice what kind of input factors are important, but also forget certain data points where the model just says, okay, this is nothing important, I don't have to keep it in my long-term memory. And of course, if you apply such a strategy, it's key to have a large data set, as large as possible. So in the first step of our project, we searched the internet for financial data on Bitcoin. We tried to find a data set that is as large as possible. Here you can just take a glimpse at what we found. And this data set, it goes back all the way until 2012, where the Bitcoin was just trading for $7. I'm sure a lot of people, or just at least a few in this room, would like to go back to those times and pick up some of those cheap Bitcoins. But this is not a topic of this presentation. And then in the end, what we also needed was live data, so that we can always, at any time and at any moment in time, just get the most recent price data on Bitcoin, give it to a model, and the model would make a prediction of where the price is going to go in the next 4 hours. But we soon noticed that price as an input factor is not enough. We needed to create some features, so we decided to calculate some of the most popular technical indicators that are used by financial analysts all around the world on a daily basis. And in theory, there are 4 types of indicators. One is for the trend, so if it's going up and down. One is for the momentum, the volatility, so how far it swings. And the last one is about the volume, so how much demand is actually for this kind of cryptocurrency in the market. And here you can see the performance of our model. It was really good, and eventually after adding all these features, picking up like larger changes. Just for your explanation on this graph, we have the blue line, which is basically our prediction, and we have from a test data set the actual price of Bitcoin. So we didn't feed the entire data set into a model. We left like a few months until the beginning of May. We left it out so that we can just evaluate the performance of our model. And even though our model was not perfect, it didn't predict the price precisely, but on average we were only off by 1.79%, which I think is already absolutely great, considering that we only put in 2 weeks of work into this project. And finally, I would like to help you grab a ticket to the moon, basically, by just visiting our website. We already have it open. We don't need to call it. We can just go here. And of course, the core of our model is the recent Bitcoin chart. You can see the recent Bitcoin data. You can see that throughout today there was actually a big spike. We are now at a pretty nice high, and we're trading in a range of between 47,000 and 51,000. And then we can do some basic financial analysis on our website. We can imply an exponential moving average. We can set the range to, let's say, 20 or something. And this is basically the average price that Bitcoin was trading in over a period that we define by 20. We can see it on this nice line. We can add Bollinger Bands, which are an indicator for volatility. So it's not expected that the price would continue skyrocketing, because otherwise we would go out of the reach of the Bollinger Bands. We can also add the stochastic RSI, just to get a feeling where the market is heading. And of course, we can make a prediction for the next 4 hours. So let's have a drum roll. Let's see what's happening. So we're only expecting a 0.5% drop in the next 4 hours. I think that's good. That's a good indice that this uprise over the last few hours is actually sustainable. And of course, without giving any financial advice, but our model would now suggest to go short on Bitcoin, if that is something that if this is a trade you're willing to do. And that's it. I would really like to give a warm thank you to Wagon for making this possible. I would give a thank you to all the teachers, all the TA who helped with so many tickets. And of course, I would really appreciate a round of applause for the other 3 cryptonauts, because also without them, this project would definitely not have been possible.
Thank you, Cryptonaut, for this amazing Bitcoin predictor. Hopefully everyone is gonna get rich. So please participate in their project by giving them €5 on PayPal. They need it. So, but money is not everything in life. Have you ever dreamt of being a great painter? I have dreamt of being a great painter, but I can't paint. So I think we can use computers to do it. And to do this, I want you to give a warm welcome to Show Me Your GANs.
All right, guys, are you ready? Yes. Thank you. So, yeah, I'll start with the introduction to why have we started this project. Some of you might know, but there's this 12-year-old kid who had the same dream as Davey, who decided to make money with computer paintings, and actually not so bad. Like, he has built some whales and he sold them for about 400K. So that's the very high-level introduction, but money is not everything. That's right, money is not everything. So on a more deeper level, we thought to ourselves and asked ourselves the question, can AI generate art? And that's also a question for you guys. What do you think? Can you raise your hand for yes? Oh, a lot of hands, that's good. But there's also some hands that didn't go up. So we also think yes. So here's our answer for that. This is our front end. So we actually built something that you can use to upload a photo you made on vacation or with your phone, like that didn't get deleted by the other app. Or and then I have another question for you guys. Who's your favorite painter? Out of these four, of course. Cézanne? Cézanne, I've heard Cézanne a lot, okay. So the question is now, can we transform this beautiful image into a Cézanne painting? So right now, what you saw, the balloons, they took the image to the clouds and made Cézanne paint a beautiful painting, tried to make a beautiful painting out of our photo. He's working right now. So as the picture group explained, our model in the background, what it does, it takes the image, flattens it down to 1 pixel, and then scales it up again. Also, we are using a cyclical generative adversarial network. So there's one machine learning algorithm working against the other. Hoping that everything will be all right. Sometimes it takes some time because up there it can get quite busy in the clouds. If heaven is full, exactly. Lots of painters there. Van Gogh also sitting there. Maybe they're competing. Against. They're competing against each other. All right, we try it again. Another round of balloons. Another. Yes, Cézanne it was exactly. So basically, what's happening here? This image is now stored somewhere on the cloud, on the bucket, which makes it available to our model to use it. So what this model does, actually, basically, it transforms the image into something that's called a tensor. So basically, it transforms the image into ones and zeros, which then allows it to apply it learned from the painter. It learned the painter. So it takes the weights of the different painters. What's weights in a neural network? It learns by weights. So what's going to happen is that it takes every pixel and transforms it as if the painter would have drawn it. So we took an image from an image library from MIT. So the artist's weights were available. So that was actually all of them were equally the same. I think for future references, the more images you have to train your data on, the easier it gets. So I would say if you self-draw sticky figures and you only have 4 input points, that will be harder than actually regenerating something that is already there. All right. So I've just heard from the technical team. We just go and jump to the presentation and go back. So actually, this an image says more than 1,000 words. which which is a bit funny because actually it was supposed to show you the results, right? But this didn't work out. So I'm gonna explain to you, like this is exactly us right now. What we just saw is we were able to upload our photo, submit our photo. This thing did not work out yet, but I'm very confident that it will in the future. So what happened in the background, we stored the photo, you upload it onto a Google Cloud. Our model was hosted within a Docker container. Basically, it packages your code into a box, sends it to the clouds, and then by using this beautiful unicorn, actually it should be able to write on the unicorn's back to get back and displayed. That's so much for the infrastructure. In terms of modeling, we use something called the generative adversarial network. As I said, briefly mentioned, two neural networks that contest against each other in a game, in which if one party gains a point, another party loses a point. So if you want to think about this in very simple terms, it's the generator that at the first iteration just generates noise. And then it gets trained so much on the dollar bill in this example until it's very hard for the other model, which is called discriminator, to identify actually if this is a real or a fake banknote. So this is in very basic terms what our model is doing, because that's basic and we didn't choose to go for it. Like no, even not. We use the model that's putting the whole thing into a cycle. So our ambition was to have a model that's not only good at generating paintings from photos, but it should also be good at generating photos from paintings. So in this case, you can see here, here's the input you give, then it generates a painting, and at the same time it goes back to generating a painting, and then it compares the two here in order to assess if the transformation of the photo into a painting was successful. I'm not going to bore you with loss functions, but then it goes back to discriminating and then making the decision if this was a photo or not. Are we having the... All right, cool. All right, back to the balloons. They fly.
All right, so this unfortunately didn't go as planned. However, I'm more than happy to show you guys now the working version of our project. Please make sure to check your Google credentials. That's just a hint I can give you guys. So, as requested by the audience, back in the days, we wanted to have a Cézanne painting, which is now being generated by the model on the platform. It's learned the brush strokes of Cézanne, and the brush strokes have been interpreted on this image now, which will be shown as this final version. Yeah, make sure everything's working and have a good time. Cheers.
Can I get a drum roll maybe? Yeah. Huge thanks to the gigantic club over here, which is consisting out of Amin, Vladimir, and Nitish, and also huge thanks to Ben for admitting our project. Huge thanks to Davey for being our TA. Huge thanks to Zuza and all the other teachers, and also thanks to all the facilities of Le Wagon, because it was an amazing journey. Gigantic thanks to everybody, and we also put some lyrical art for you here. So yeah, please enjoy, and also amazing job to all of the groups that have been here before. Your models did work, and yeah, this is my mic drop. Thank you.
So we went to the moon. We generated a fake painting, almost. I think it's time to go back down to Earth. When I arrived in Berlin, I discovered that the German elections will be coming soon on September the 26th, right? And I would be curious to predict the polls. And to do this, we have the Delphi groups coming on stage.
Thank you very much, Davey. So the Delphi project, derived from the ancient famous Greek oracle, we basically want to create a tool which more reliable or more accurately than polls depicts the opinion of the people on a given topic. And for our project on these 2 weeks, we chose the German federal election, which will be held on September 26th. But let's take a step back on what are the actual problems with traditional polls. Now, first of all, they're usually being conducted over 3 to 5 weeks. So if, for example, a scandal were to happen on the last day, the poll wouldn't really pick up on that. Then secondly, usually people are shy to tell their real opinion when it comes to matters that are of a more extreme nature. For example, during the 2016 presidential election in the USA, we saw that the polls didn't really pick up on the trend of people thinking that Donald Trump is a great choice for president. And lastly, polls are expensive. You have to hire a team that questions people, and that just adds up. But how can we improve on this? Basically by taking the largest real opinion site in the world as additional information to our polls, Twitter. Over the last 5 weeks, we collected 1.3 million tweets on the presidential election, and in combination with the polls, we try to generate a more accurate outcome of the election if it were to happen today, just like normal polls. Let's take a basic look at our workflow. We collect the tweets from Twitter. We label it whether it's a positive or negative tweet. Then we generate some numbers out of that, which we will use in a deep learning model to make an outcome of the election if it were to happen today. But let's take a closer look at each of these steps. Now, every day at midnight, we make a call to the Twitter API. An API basically enables our program to communicate with Twitter servers where they store all tweets up until 2006, and it allows us to access data from Twitter. Now, we don't only make one, we actually make 7 calls, 6 for the major parties currently in the German parliament, and then 1/7 because actually there are 53 parties being permitted to the election, but as a short introduction to German politics, you need 5% to actually be in the parliament. So we're combining all the other parties into one party labeled others, just as also polls do it. Now that we have our tweets, we want to basically know the mood of the tweet. For that, we are using natural language processing, which is basically just the automatic detection of text. Automatic because although my team worked pretty hard during the last 2 weeks, we definitely could not label or read 1.3 million tweets ourselves. Now, depending on the words being used in a tweet, it will label it as either positive, negative, or neutral to one party. And out of this, we generate numbers of interest for our model. For example, the feature so-called, for example, weighted sentiment is a combination out of the likes and retweets with the sentiment being given of one tweet. And this combined with the most current polls makes up the data for our model. Now, as a deep learning model, we chose recursive neural networks as we are using here data over time, which is time series data. But the problem with these is that they usually tend to forget events that have happened in the past. And to counteract this, we're using a subgroup of RNNs called LSTMs, which are long short-term memory models, which basically just they have a better memory than basic RNNs. And out of this, we get 7 percentages if an election were happen today, how the people in Germany would vote for the different parties. But now that we have our numbers, let's see how you can actually check them out on a daily basis.
Thank you, Nicholas. Hi, everyone. So, yeah, as Nicholas already explained to you where we actually get our data from and how we transform it in order to come up with a prediction, which is hopefully better than the polls. the last important step, which is still missing, is to make this a prediction and also some other insights that we retrieved along the way available to you and everyone who's interested in the topic. So in order to do that, we built a website which is live today, so everyone can access and will be live until the election. So, and how does it work under the hood? So all the data, or at least some of it that we retrieved along the way, we uploaded it to Google Cloud Platform. Google Cloud Platform is just a service provided by Google, and they also have cloud storage similarly to Google Drive. So we upload our data there. And our website, which is deployed on Heroku, just a hosting provider, downloads this data every time you access our website and displays them in a nice interactive dashboard. So, but now let's stop with the theory behind it and just have a look at the actual product. This is our dashboard. You can access it as well. So first of all, who will win the election if the election would have happened today? SPD and Olaf Scholz. So on the left-hand side, you see like the outcome of the election based on our prediction of our model, so the parliament. And on the right-hand side, we compared these to the most current poll of today. So as you can see, we are pretty close to the recent poll, like of today, and the highest party is SPD. This is kind of interesting because if we scroll down a little bit, you actually see that the trend a few months ago was quite different. So here this chart basically displays the history of polling data over the last 2.5, 3 months. And here in July, CDU was still at 30%, while SPD was at 16%. But this trend changed over time. There were some scandals involved, floods happening in south and western part of Germany, and now SPD actually has a huge trend going upwards, while CDU is going down. So, and there's another feature of our website, which I really like personally, because since we had access to so many tweets and Twitter data, we thought it would be really nice to share some insights with you as well. So here you can see some of our metrics that we derived during the process. For example, how many tweets were there about what party of yesterday, and also what was the sentiment per party of these tweets on average or overall. And as you can see, and I think that's not a surprise, most people tend to use Twitter more to, let's say, criticize and not to share like love or positive feedback, which you can see here is like only 10% of the tweets are actually positive for all the parties, but around half of them are negative. I guess it's not a surprise. And if you even scroll a little bit more down, we also show you the most liked and most retweeted tweets of the day, or of yesterday. And on the left-hand side, there's always a positive tweet. On the right-hand side, there's a negative tweet. This is the overall, but if you say, hey, I'm more interested in one specific party, you can also filter for that party. Let's say CDU, for example, the trend is going down. So our charts change, and we also see that the tweets change. So yeah, as I said, the website is live. It will be live until election. So if you want to check out who will win the election, check out our website on September 26th in the morning, and you will know before everyone else. And yeah, last but not least, there are two people missing on this stage, Luca and Finn, who also did an amazing job during the project, and also thanks again to Nicolas, because he actually came up with the idea for the project, and it was an amazing ride. Also thanks to all our TAs, teachers, Wagon. Without them, we wouldn't be able to show our product. Yeah, thanks again, and that's it, folks.
So, last but not least, yes, last already, can you believe it? So the last group, the idea was actually pitched by my man René, who's sitting in front here. And for those of you who didn't know, René at the beginning of the bootcamp was on the brink of dropping out. And we actually convinced him to stay. And I'm super proud to have him here today to see his own idea come to life into an amazing product. So please make some noise. He's going to come up here to present his product along with Anita. Make some noise for Fairjobs.
Forget Anita. I'm Emma. Hi. I'm 35 years old. I have 2 children. I'm living in this wonderful city called Berlin. I love hiking and meeting friends over coffee or beer. And I work as a data analyst in a mid-sized company. And to be honest, I don't really like working there. Why? Because I'm working in a male-dominated environment. I earn less than my male colleagues, and I'm constantly stressed due to long, unflexible hours at the office. Can you imagine? No remote. So I'm looking for a new job. And what I'm looking for is a company that has a company culture that is based on values like trust and support, that has an inclusive environment, including a fair and transparent compensation, a flexible working settings, so that I can have a good work-life balance, and last but not least, a climate that ensures growth and learning. So I don't know how you do it, but when I'm job hunting, I'm doing it online. I'm looking for the role I want to fill on different websites and job portals like Indeed and Stepstone. And on these portals, I'm checking out a lot of job offer. Unfortunately, often I do not really feel spoken to due to male-focused imagery and job description, as you can see here as an example of a data scientist. So when I find an interesting job offer, I'm researching the company behind that. And probably you can imagine that takes a lot of time, and it's quite frustrating because often I do not find all the information I'm looking for. So I heard about this new website created by data scientists. They're doing something like text and image analysis and so on. And if you like, you can look over my shoulder why I'm using it, why I'm trying it out. So I'm looking for the position of a data analyst. And I can already see there are many possibilities for me to personalize my search. So I'm deciding for a feminine tone of job description. And I can set priorities for criteria like company culture, flexibility, inclusion, and personal development. So I then click search, and I have read that there will be lists of job offers. They are already sorted by the by relevance score that is based on my personal settings, and there will be a maximum of 10 results. We will see how much we are getting out for my personalized one. Wonderful. Okay, so let us look at the first one. This will be the most relevant for me based on this relevant score. And we see more detailed overview over the scores. So there is something like female coded and male coded. I'm sure this is the base for the setting of feminine or masculine tone of the job description. There's something like a picture score. This shows how many women are depicted on the company's website or Facebook Facebook page compared to men. And there is the already mentioned relevance score and the connected unique criteria scores like company culture, inclusion, and so on. And I can see there's also the job description, and that's curious. It's like quite colored. When I look further, I see that the red color-coded words are female labeled, the blue ones are male, and there are even yellow ones that say neutral. I don't know how you feel, but I already have the feeling that I got a really good overview over the company that is behind this job offer. That would have taken me a lot of time earlier, but now we did it in like 2 minutes. So I love it. And I hope you do it too. You can also use that. It's live. I will now hand over to Renee, who is describing more the technical aspects of our project.
Yeah, I'm super proud we presented you the first gender equality and diversity and inclusive selecting search engine in the world. So it really can do this stuff. It's not made up. We didn't do the colors by painting. Behind this search engine are super smart algorithms called the Gen rank, which helps us to rank these job offers. And at first, actually, what it does, it's pretty simple. So, no, can you go up again, please? So, what it does, actually, it's the simple thing. It's just telling you if the job description is female coded or male coded. So, this is actually what it's doing. And how it is empowering you. So, we use the smart algorithms and artificial intelligence in the background to show you and to make it transparent and help you to analyze what does female coded and male coded mean. So we are not capable by reading the text and telling in a few seconds. Right now, I think you can see it. This is blue dominating and this is red dominating. So it's very simple for everyone to analyze and identify what does it mean to be female and male coded. The biggest insight which I got was, for example, this is that most of the words which are male coded, this is the male coded job description as data inside. So I feel like, okay, it's male coded, but actually it's not discriminating women. So this was the insight which I could make, and you can make too in seconds, which would take like a lot of time if you do it by yourself, by reading all of them, right? So this is one of the improvements. We make it for everyone, so it's super inclusive for everyone possible to make this analysis in seconds. So how does it work? What is the magic behind? It's called natural language processing. So we created a text decoder. As you saw how Anita showed that it's possible to make these filters and to rank them by the tone. We used, based on a scientific paper, a bunch of female coded words and a bunch of masculine coded words. Based on them, we could look at every 25,000 job offers. It could be like millions. It's working. It's a real working algorithm. So we could have millions, classify millions of job descriptions. If there are female words inside and masculine words inside, and based on which is more dominant, we can classify them into female coded and male coded, as you have seen before. But I have a super smart team. We just didn't use the scientific approach. We worked with a similarity algorithm, which created, with the help of Wikipedia, a huge amount of words which are similar to the words we already have. So we have like an army of words which are female coded and male coded, which increases the quality of the search to make to find and classify much better the job descriptions that we have. So this is the text decoder. The second feature is the personalizer. You saw how Anita, how easy it was for her to find the perfect or the most fitting job description to her search, right? This is not possible right now. There's no filter outside which can do it for you. We created this filter. How does it work? Actually, it works the same approach how we did it before. So instead of the scientific approach, we created our own criteria and keywords. Based on these keywords, the company culture, for example, and the inclusion, it's searching in our database. We used 22,000 job descriptions, and it can tell you how many of them are matched. So how good is the company culture and how many of the inclusion words are matched. And you can add your weight, so your own personalization, and it will give you the score to show you and rank the description which perfectly matches to your preferences. This is the second feature. The third feature is, this is just this small score. In the front end, it looks like super boring. In the back end, I have to thank my team, especially Greg, who built this super smart algorithm in just 1.5 days, or I don't know, it was super fast. How does this score, how does it come up? So at first, we looked at many companies out there put on their website that we are inclusive, we support women, or we do empowerment. But we wanted to prove if they really do. So we looked at all the pictures of these companies on their website, on Facebook. We collected all of their pictures, and we wanted to know if they represent women equally to men. Just to prove if they really do what they say, right? Are the women fair represented? So with the help of a convolutional algorithm, it is possible to classify if there are women or men in the picture. Well, but this didn't help us. We still didn't know how do we identify pictures, the people in the picture. So we created a deep learning model which helps us to identify if there are humans inside this picture, and if they're, actually just to identify if they're in the picture. So this is the one algorithm which is combining with the other one, and this can help us to count how many women are in their pictures and how many men are in their pictures. Based on this ratio, we have this score here, and if the score is 100, it's like equally. If it's above 100, there are more women represented. If it's below 100, it's women are underrepresented. So the sad thing about this research was that we never found a company that represents more women than men in the communication. So this is what we can do. So it's a very, very powerful feature. Yeah. All in all, the vision of this project is to combine all these scores. We didn't do it yet. But the vision is to combine it to make a powerful algorithm called GenRank. So it takes all the results together and creates a relevance score. And by this, you can identify which are the most equal, equality empowering companies that care for inclusion and diversity. Thank you. So this was not just my work and Anita's. As I told you, a big thanks to Grégoire. I think you did an amazing job. And thank you so much to Kumil, who, please stand up, Kumil, amazing. Yeah, and of course, not only the team, it was Michael, where are you, man? Thank you so much. Without you, this wouldn't be possible, and of course, everyone from Wagon. Was a great journey, and I'm super proud that we were capable after this bootcamp to create such an amazing solution. Thank you so much.
So this wraps up batch 672, people, minus the party. Sorry, I've been told to move around here. Amazing products, a massive well done to all of you. If we just go back 9 weeks ago, you guys were struggling on Python lists, and now you created all these amazing products. And actually, you made tickets to me that I had no idea how to solve, and that you solved yourself. So it's the moment where students become the masters, and it's always so rewarding for us. So massive well done to all of you. Be proud of yourselves, and I think you can give yourselves another round of applause. So it's the time for the thank yous. I want to thank a bunch of people. First of all, I want to thank the teaching squad for the projects who are sitting back there. Dominic, Michiel. We had Simone, who unfortunately couldn't make it today. And Toby also. Let's not forget Toby, who's sick at home, but hopefully he's watching us. So thank you guys, because you guided your groups to really amazing products. Really well done. I also want to thank the whole teaching squad of the entire bootcamp, because obviously not everybody can make it today, and it's a lot of TAs and teachers that put a lot of effort to put you in the best conditions for learning. Hopefully a lot of them joined today, so a massive thank you to all of you for crushing tickets, doing amazing lectures, and just bringing good vibes. Thank you so much. Yes, yeah. Yes. I want to thank the whole Wagon team, because it's not just the teachers and the TAs. There's a whole team behind that makes the delivery of this bootcamp possible. I'm thinking of Annie, Mariette, Tom, who's right there, and many others. Thank you so much. And last but not least, I want to thank my bandit squad, Zuza and Davey, for making such a great team. Thank you so much.